In this video, we'll look at how to inspect HTTP, HTTPS, and DNS traffic in Wireshark. For penetration testers, analyzing these protocols help uncover sensitive information, understand how applications communicate, and spot potential weaknesses in network security. Let's start with HTTP traffic. I'll begin capturing on my active network interface, and then I'll visit this website on my browser. This is an HTTP website that lets you post data. I'll enter some random information on this form and I'll hit login. Back in Wireshark, I'll stop the traffic and apply HTTP filter. Now let's take a closer look at HTTP post request in Wireshark. Post requests are particularly interesting for pen testers because unlike GET requests, which usually carry parameters in the URL, post requests often send sensitive data like usernames, passwords, or form inputs inside the request body. To analyze this, I'll select a post request packet from the capture. In the middle pane, under the Hypertext Transfer Protocol section, I'll expand the details. Here, Wireshark shows us important headers such as host, user agent, and content type, which can tell us more about the client making the request. If I scroll further down, things start to get really interesting. For example, in this form URL encoded tab, we can see the username and the password I just entered on the website. This visibility is what makes capturing HTTP traffic so valuable in penetration testing. It clearly highlights why unencrypted HTTP is a risk. Attackers on the same network can capture traffic and directly view sensitive data. Of course, in the real world, HTTPS is the standard and prevents this kind of snooping. But misconfigured servers, legacy applications, or overlooked endpoints will still expose credentials over HTTP. As pen testers, spotting this kind of traffic quickly reveals weak points in an organization's security posture. Now let's analyze DNS traffic. I'll clear the capture and start again. This time, I'll visit wikipedia.org. I'll stop the capture and filter with DNS. Here's a request, a standard query for the domain name wikipedia.org. And here's a standard query response, which resolves the domain to its corresponding IP address. For attackers, this information is useful because it reveals which domains a target system is trying to reach, even if the actual web traffic is encrypted. DNS analysis can also help detect tunneling or suspicious communication with malicious domains. Now let's take a look at HTTPS traffic. I'll start a new capture. In this time, I'll visit google.com. I'll stop the capture, and if we filter with TLS, all we can see is the TLS handshake packets. We can no longer read the actual HTTP requests or responses. Instead, all we see are the handshake, certificate exchange, and the encrypted application data. This is both the strength and limitation of HTTPS. For defenders, it secures user data from eavesdroppers. For pen testers, it means we cannot directly inspect payloads without additional techniques such as man in the middle interception or using the server's private key. So while HTTP gives full visibility, HTTPS hides the sensitive details. To summarize, HTTP traffic can expose get and post requests in clear text. DNS traffic shows domain lookups and replies, which can reveal user activity. HTTPS protects data with encryption but limits what we can see in Wireshark. For penetration testers, understanding these differences is crucial when analyzing network captures during assessments. Thanks for watching.